Today we're going to talk about absolute value equations. With absolute value, remember that it's the distance a number is from 0 on the number line. So the absolute value symbols, remember, are the two bars. For example, if we have the absolute value of -7, well, we have to think about the distance -7 is from 0. So distance is never measured in negative. So the absolute value of -7 is +7. Same with if we had the absolute value of 8. Well, 8 is 8 spots away from 0, and it's going to be +8. Okay, absolute value equations. So we're going to add some variables in here. We're going to have variables mixed with numbers, and we have to solve for the given variable. So this is the setup for our problems. So we've got absolute value of A minus B equals C. It's not always going to be all letters. This is just a generic example. But based off of the original problem, we're going to have two cases. We're going to have case 1 and case 2. So in case 1, notice it looks the exact same as the original problem. Nothing's changed. So case 1, same. Then for case 2, you notice that from the original problem to case 2, the sign changes on the right. So just make a note here, change sign of terms on right. So case 1 is the same as the original. Case 2, you change the sign of the terms on the right-hand side. There's something else that we need to talk about, and that's extraneous solutions. So every once in a while, whenever we solve one of these, you're going to go through the check step process, and even though you solve the problem correctly, when you plug it back into the original problem, it does not check out. So we'll talk about what problems you need to do the check step on and when that doesn't work. You're not going to have to do the check step for every problem, but pay attention in these notes. Whenever I do the check step, that's when you need to do the check step as well. Okay, so here's the steps for solving. You're going to want to pause this video so that you can write these down. The first thing that you need to do is isolate the absolute value bars. So sometimes there's going to be terms outside of the absolute value bars on the same side of the equal sign. You're going to have to move those numbers over until the absolute value bars are by themselves. The next step after that, you're going to set up case 1 and 2. Then after the cases are set up, you're going to solve each case individually. The solution should not be the same. And then sometimes you're going to have to check your answer back in the original problem. And then after that check step, you'll have to decide which solution is true and which one is false. Okay, first example, it says, what's the solution of absolute value of 2x minus 1 equals 5? Absolute value of 2x minus 1 equals 5. So the first step is to make sure the absolute value bars are by themselves on the left-hand side of the equal sign. So there's nothing outside of them, so they are by themselves. So we can go ahead and set up case 1 and 2. And your work for these problems really needs to be organized. So the way that I show how to solve it would be a good way for you to organize it as well. So case 1, remember we said looks the same as the original. I get rid of the absolute value bars when I'm doing this process so that I can solve them. But when we do a check step, we have to have the absolute value bars still there. Okay, so case 1 looks the same. Case 2, the left-hand side never changes, so it stays 2x minus 1, but the 5 turns from positive to negative. All right, our two cases are set up. Now we need to solve. So I'm going to start with case 1, add 1 to both sides. 5 plus 1 is 6. Divide by 2 on both sides. X equals 3. Okay, case 2, need to solve this. Add 1 to both sides. 2x equals -4. Divide by 2. X equals -2. Okay, so let's talk about the check step. So the check step is only necessary when there's a variable on the right-hand side. So because we only had 5, which was a constant number on the right, we don't need to do a check step, and we can go ahead and circle these as solutions. So again, we only do a check step when there's a variable on the right-hand side of the equation. Okay, problem 2, it says, what is the solution of absolute value of 3x plus 2 equals -3? So first step we need to do is look to make sure that the absolute value bars are by themselves. They are. So the next step here would be to set up our two cases, but there's something that I notice, and that is that the absolute value bars are set equal to a negative number. So remember in the first couple of slides we talked about, well, absolute value measures distance. So if I plug a number in for x here, so if I plug a number in for x, any number in the entire world, whatever comes out of those absolute value bars is going to be positive. So I'm never going to have a positive equals a negative. So when the absolute value bars are by themselves equal to a negative number, the solution isn't possible and it's no solution. So you've got to pay attention when the problems are there, because you really don't want to go through that whole process of solving two cases when the original answer is no solution. So make sure that you're paying attention. Okay, next problem. We've got 3 times the absolute value of x plus 2 minus 1 equals 8. So first step is to always make sure the absolute value bars are by themselves on the left-hand side of the equation. So right now they aren't. So I need to get rid of the 3 on the outside and the minus 1. So we always get rid of the subtraction first. So I'm going to add 1 to both sides. So then I've got 3 absolute value of x plus 2 equals 8 plus 1 is 9. Okay, then a lot of times students want to take that 3 and distribute it into absolute value bars. You can't do that. Absolute value bars are not the same as parentheses. So we've got to get rid of that 3 in a different way. So right now the 3 and the absolute value bars are being multiplied. The opposite of multiplying is dividing. So I'm going to divide both sides by 3. It cancels out there. I'm just left with x plus 2. And 9 divided by 3 is 3. Okay, this is my new problem that I'm going to base my cases off of. So case 1 is x plus 2 equals 3. Case 2 is x plus 2 equals negative 3. I changed the sign of the number on the right. Okay, now I need to solve. So I'm going to subtract 2 from both sides. X equals 1. Case 2, I'm going to subtract 2 on both sides. X equals negative 5. Do I need to have a check step for this problem? Are there variables on the right-hand side? No. So that means x equals 1 and x equals negative 5 are true solutions. Next example, absolute value of 3x plus 2 equals 4x plus 5. Absolute value of 3x plus 2 equals 4x plus 5. So first thing, absolute value bars need to be by themselves. They are. So I can set up my two cases. Case 1, 3x plus 2 equals 4x plus 5. Nothing changed. Case 2, 3x plus 2 equals negative 4x minus 5. So even though there were multiple terms on the right-hand side, both of them changed signs. So the 4x became negative, the 5 became negative. All right, now I need to solve. So for case 1, I'm going to subtract 3x from both sides. 2 equals x plus 5. And now I'm going to subtract 5 from both sides. 2 minus 5 is negative 3 equals x. All right, case 2, I always want to move the smaller variable, so I'm going to add 4x to both sides. So 3x plus 4x is 7x. And then I'm going to subtract 2 from both sides. Negative 5 minus 2 is negative 7. And divided by 7, x equals negative 1. Okay, so now we have to look to see if we need to do a check step or not. So remember, the idea behind that is if there's variables on the right-hand side, then we need to do a check step. So since there's a 4x, that means check step has to happen, and we have to do it for both cases. So check step 1, when you're doing the check step, it goes back into the original problem. So that means the absolute value bars are there, and all the signs are the same as they were when they first started. So I've got absolute value of 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. So all I did was take the x's out and replace them with negative 3, which was my solution. Okay, now I have to just solve and see if the two sides equal each other. So 3 times negative 3 is negative 9. 4 times negative 3 is negative 12. All right, negative 9 plus 2 is negative 7. Negative 12 plus 5 is negative 7. Now the absolute value bars are there, so this needs to go a step further. What's the absolute value of negative 7? 7. Does 7 equal negative 7? No. So that means we cross this one out. Even though we did the whole process right, negative 3 is not a true solution for this absolute value equation. Okay, check step 2. Again, this goes in the original problem, so all of the signs are the same from the beginning problem. I'm repeating this, but there's still going to be students that mess up and they want to plug it into the check step. So you have to plug it into the original. All right, 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. Again, same thing. We need to see if the two sides equal each other. So 3 times negative 1 is negative 3. 4 times negative 1 is negative 4. Negative 3 plus 2 is negative 1. And negative 4 plus 5 is 1. Absolute value of negative 1 is 1. Does 1 equal 1? Yes. So that means we can circle x equals negative 1 as our solution to this absolute value equation. All right, you're going to get lots of practice with this concept. Your homework is going to be on Google Classroom.